Good day everyone, welcome back to class. Alright, so we are still on limits and we started solving examples right from the last class. So again we'll be moving again on the examples. Alright, so limits, examples. I can remember I stopped at example 5 for us last class. So let's move to example 6. Example 6 says we should link x squared minus 1 over x minus 1 as your x tends to 1. If we try to substitute this directly, that's 1 squared minus 1 over 1 minus 1, which will be 1 minus 1 over 1 minus 1, and that's 0 over 0. Don't forget I told that our answer must not be 0 over 0. We have to do everything possible to avoid that. Alright, so you can actually use difference of 2 squared for the numerator part. So meaning I can write this as x minus 1 and x plus 1, right? So then we can say ln x tends to 1 of our x squared minus 1 over x minus 1 now can be ln x tends to 1 into x minus 1 x plus 1 over x minus 1. This can cut this, so we have ln x tends to 1 into x plus 1. So x plus 1, which cannot be anywhere you see x, just put 1. That's 1 plus 1, which is 2. 1 plus 1, which is 2. That's how to solve that. Alright, so number 3, we have ln h tends to 0. Then we have square root of x plus h minus root x over h. Now, if you say you should substitute this directly too, you can actually have square root of 0 plus h, right? Minus square root of h over h, and this will be square root of h minus square root of h over sorry for that. I mean we input 0. Anywhere we see h, we input 0 rather. So anywhere we see h, we input 0. So that will be x plus 0 minus root x, right? And our root is over h now is 0. That's root x minus root x over 0, and that will be 0 over 0, right? That will be 0 over 0. Alright, so now don't forget I already told us that we are trying to avoid that. Okay, so now anytime you have this kind of question, what you have to do is you multiply the numerator and denominator by the conjugate. Remember your conjugate in sword. So meaning I can write this as ln h tends to 0 of this minus root x over h. So I will multiply the one up and the one down with the conjugate of the numerator, which is actually this, plus. It will now be plus now, not minus. That's the conjugate. Then over, you do the same thing for the denominator too. Alright, so this can also actually be written as ln h tends to 0 into root x plus h minus root x, then root x plus h plus root x over h into root x plus h plus root x. Okay, so from here we have ln h tends to 0. For the numerator, the upper part, we can actually make use of difference of 2 squared. So we'll pick the first component, which is this, all squared, minus we pick the second component, which is this, all squared, over h into square root of x plus h plus root x and this can be written as ln h tends to 0 into, this can cancel this can cancel this, your square can cancel your square root, so we have x plus h minus x left over h into root of x plus h plus root x. Alright, so x minus x is equal to 0, so we are left with ln h tends to 0 into h over h another bracket to root x plus h plus root x plus root x, which is the same thing as ln h tends to 0 into our h can cancel our h here, so we are left with 1 over root x plus h plus root x. So we can substitute now, meaning anywhere we see our h we put 0, so that will be 1 over root x plus 0 plus root x, and that will be 1 over root x. X plus 0 is x, right? So that's 1 over root x plus root x, which is 1 over 2 root x. 1 over 2 root x. So that's how to solve that. Very simple and very straightforward. Very simple and very straightforward. Alright, so let's look at another one that actually looks like something like that. Let's look at another one that looks like something related to that. Alright, so lim, which is, I guess that should be our example 8 if I'm not mistaken. Lim x tends to 1, and we have this root x minus 1 over x minus 1. Root x minus 1 over x minus 1. Alright, for these two, we can actually multiply up and down by the conjugate of the numerator, just like the way I solved the last one. So meaning I can do this minus 1 over x minus 1, and this will be times root x plus 1, and this will also be root x plus 1. Alright, so we have ln x tends to 1 into, this will be root x minus 1 and root x plus 1. The upper part will be, the lower part will be x minus 1, right? Root x plus 1. Alright, so we can use difference of 2 squared for the upper part, meaning I will pick the first component, root x all squared, minus I will pick the second component, which is 1, so that's 1 squared, over x minus 1 and root x plus 1. Root x plus 1, which is ln x tends to 1 into, this square can cancel this square root, so we have x minus 1, because 1 squared is 1, over x minus 1 and root x plus 1. So this can cut this, and we have ln into 1 over, we are left with root x plus 1 at the down part, so x tends to 1. So now it's easy for us to substitute directly here. It's very easy for us to substitute directly here. So using directly here means it can be 1 over square root of 1 plus 1, which is 1 over 1 plus 1, because square root of 1 is 1. And the answer here will be 1 over 2. The answer here will be 1 over 2. So let's take the last example in this class. Then we look at other example in my next video. Alright, so ln x tends to 7. And we have this function 2 minus root x minus 3 over x squared minus 49. So I already told us what to do. You multiply up and down by the what? By the conjugate. So meaning I can write this as ln x tends to 7, because if you try to substitute directly, you know you have 2 minus root 7 minus 3 over, this will be 7 squared minus 49, and that will be 2 minus root 4. 7 minus 3 is 4, right? And 7 squared is 49. That will be 49 minus 49, which gives 2 minus 2 over 49 minus 49, and that's also 0 over 0, which we are trying to avoid. So we cannot substitute it directly. Alright, so moving on now, meaning I will have to multiply the numerator and the denominator by the conjugate. So this one, then the conjugate is 2 plus, right, x minus 3. Then the down part also is x squared minus 49. And we also have here 2 plus x minus 3, square root of x minus 3. Okay, so we have ln x tends to 7. So don't forget we can use difference of 2 squared. Pick the first component, 2 squared, because it's still the same thing 2 root x minus 3, but the first one has minus in between and this next one has plus in between, so you can use difference of 2 squared. So that's 2 squared minus, repeat the second component, root x minus 3 all squared, then over the down part we have x squared minus 49 into 2 plus root x minus 3, 2 plus x minus 3. Alright, so don't forget square can cancel square roots here, so we have ln x tends to 7 into our 2 squared means 2 times 2, which is actually 4, minus x minus 3. Don't forget to use your brackets because it's complex. X minus 3, put it inside your brackets. Over, for the down part too, we can actually write it as, it is s squared minus 49, which is actually x squared minus 7 squared, right? And that will be x squared, using difference of 2 squared, s squared minus 7 squared, which is x minus 7, right? And x plus 7. So my x squared minus 49 now will be x minus 7 and x plus 7. Yes. So now we have 2 plus root x minus 3. 2 plus root x minus 3. Alright, so ln x tends to 7 now. Into this can be 4 minus x plus 3, right? Over this can be x minus 7 and x plus 7 into 2 plus root x minus 3. Yes. Alright, and that gives ln, don't forget x tends to 7 is until you substitute and you remove that limb. Once you've not substituted, you keep writing that limb. Alright, so into this can be minus x plus 7 over x minus 7 x plus 7 into 2 plus root x minus 3, root x minus 3. Then we write this as ln x tends to 7 into minus x plus 7 actually can be written as minus into x minus 7, right? Yes. Now what I did is I tried to factorize the negative, so that will be minus into x minus 7 over, this will be x minus 7 x plus 7 into 2 plus root x minus 3. Alright, so this can actually cancel this, so we have ln x tends to 7 into minus 1 over x plus 7 2 plus root x minus 3. Alright, so it's easy for us to substitute now. We can substitute now. So by direct substitution, we have minus 1 over, this should be 7 plus 7. Our x is 7, so that should be 7 plus 7 into 2 plus root 7 minus 3, and that gives minus 1 over this should be 49, sorry, this should be 14. 7 plus 7 is 14, right? So this should be 14 into 2 plus square root of 7 minus 3 gives 4. Good. Okay, so that will be minus 1 over 14 into 2 plus square root of 4 is 2. So we have minus 1 over 14 into 4. Yes, minus 1 over 14 into 4, which is minus 1 over 14 times 4 gives 56. That's how to tackle that kind of question. Alright, so we'll be looking at more examples in my next video. Thank you. God bless you.